All right, we're going to talk about data displays. The really only new information that you haven't seen before, or maybe you just touched on but really haven't talked about too much, is the box and whiskers, and that's going to be at the end. All right, what are the names of the graphs? The graphs. This is a stem and leaf plot. We're going to be talking about those. This is the box and whisker, which we're going to be getting into. This is a histogram, not a bar graph. That's a histogram. And then that's a circle graph. We're really not going to be talking about circle graphs too much. All right, so stem and leaf. The big thing that people forget is that you need to look at the key, okay? Because the key tells you what the whole thing means. For instance, in this example, 24/1 equals 24.1 seconds. So this would be 24.1, 24.9, 25.0, 25.1, and so forth seconds. All right, so a stem and leaf plot lists all data values in an organized form using specific intervals. So for instance, if this is time it takes students to get ready for school in minutes, we would take all these values and we would put them in order from least to greatest, which how nice it already is. Then to make our stem and leaf plot, let me see if I can move this. Okay. Then to make my stem and leaf plot, I would say, okay, the key is 2-3 equals 23. Okay, so then I start with my first. So your stems are your tens. So my first stem is a 2. I've got 23, 23, 25, 27, 28, 28. Then I would go to my 30s and then knock them off as you're going. Then I would go to my 30s. I've got 33, 34, 35, 37, 37, 37, and 39. And then 40. So 40, 42, 43, 43, 45, and 48. Now, honestly, I know I put commas, but a lot of the times you won't see the commas. So, then I don't know why I put commas. So take those commas out. You shouldn't have commas. It should be 3, 3, 5, 7, 8, 8, and then 3, 5, 3, 4, 5, 7, 7, 7, 9, 0, 0, 2, 4, 3, 5, 8. My bad. Oh, and then the last one's 58. So 5, 8. All right. That's pretty simple. I'm not really going to ask you to make stem and leaves. I'm just going to ask you to interpret them like this. How many students take 37 minutes to get ready? 37 minutes. So 37, 37, 37. So 3 students. Okay. Hourly wages. What does 7 dash or line 2 mean? Well, if I look at the key, it says that 6-5 means $6.50. So 7-2 must mean $7.20. All right, so we're going to go ahead and let's make one more real quick. So drag the digits from the box to make a stem and leaf plot for the data. All right, so we're going to, actually, let's skip this and we'll do it at the end. So I don't think we need really time about this. Let's go to histograms. All right, histograms are similar to a bar graph. It shows data in equal intervals. Unlike a bar graph, the histograms bars touch, and they're all the same width. So they're going to touch. Is there anything down here? So this is a histogram. Okay, versus a bar graph looks like this. They don't touch. Okay. All right, how many students use the internet for at least 31 minutes? All right, so you got to think of the difference between at least and at most. So at least, remember if I write it, you write it. At most. So at least means it's the minimum amount. Right? So it's got to be that or more. So it's or more. At most means it's the maximum amount. So, or less. So if we read this again, how many students use the internet for at least 31 minutes? Well, 31 is here. And if it's at least, that means it's the minimum. So now, from 31 to 40, there were 18 students. From 41 to 50, there were 14. 51 to 60, there are 17. And then 61 to 70 is 11. Now I just got to add them up. So 18 plus 14 plus 17 plus 11. What does that give me? 12, 19, 20. Carry your 2, 3, 4, 5, 6. So 60 students. What percent of the students used the internet between 11 and 20 minutes? So 11 and 20 minutes is here, and that is 6. Okay, so we have 6 people over. Now we need to figure out how many total there are. So this would be 9, 18, 14, 17, and 11. So let's find the total by adding up 6 plus 9, 18, 14, 17, and 11. So if you just grab your calculator real quick. 6 plus 9 plus 18 plus 14 plus 17 plus 11. So there's a total of 75 people. So now we're going to put 75, so the total goes on bottom. And it says what percentage. So we take that we take that fraction, we turn it into a decimal, which is 0.08. And then to make that into a percentage, we double dip to the right. So that would be 8%. All right, box and whisker. So this is the one that's new. This is the one that we're going to be talking about in more detail. Okay, box and whiskers. I'm just going to give you, I know this says to watch a video. We're not going to watch the video. I'm actually just going to talk about it, but let me get this out of the way. Okay. All right, this is what a box and whisker plot looks like. And they all look different. But the basics are the same. This out here is your minimum point. Out here is your maximum. Those are your whiskers, okay? Your minimum point, maximum point. This inside is the box, okay? So this is your Q1, aka your lower quartile. This is your Q2, aka your median. And this is your Q3, aka your upper quartile. Okay? So I'm going to show you exactly how to find all this given your calculator. This, the box part, is going to be your interquartile range. Okay, and remember the range is just the larger point minus the smaller point. So it's going to be our Q3 minus our Q1. Okay, the big deal here is this is broken up into 4 parts. This is one part. This is another part. Here's a third part. And here's a fourth part. Each part is worth 25% of the data. So if I asked you how much of the data is from the minimum to the Q3, I just counted up. I would say 25, 50, 75% of the data. If I asked you how much of the data is in between the Q3 and the maximum, you would say 25% of the data. Okay, that's a biggie. Let's get down to some of the questions. All right, so let's go ahead and make one real quick. So the first thing we're going to do is we're going to grab our calculators and we're going to put those numbers into our stat plot. So grab your calculator, you go to stat, edit, clear out anything you currently have in there. And then now we're going to put in our values. So 4, 10, 10, I don't know what else we have, 14, 4, 25, 14, 4, 25, 20. Oh, it wasn't 20. It's 15. All right, 15, 22, 16, 10. 15, 22, 16, 10. 15, 22, 16, 10. 15, 22, 16, 10. All right, so those are my data points. Now I go to stat, calculate one variable statistics. And all these things come up that you're like, what? If you scroll down all the way to the bottom, this is the only thing that we want to know right now. Okay? So our minimum is 4. So I can go ahead and grab this. Our minimum is at 4. And that makes sense, right? 4 was our smallest point. Our max is at 25. Oops, didn't mean that. The max is at 25, which would be over here. Okay, now let's find our Q1. Our Q1 is 10, our Q3 is 16. All right, so Q1 is 10, Q3 is 16. And then what is our median? Our median is 12. Okay, so now we can combine, or we can go ahead and draw. So remember, this is straight, and then we make a box. Okay, so there's our box and whisker. Now, the lower extreme is the same thing as the Q1. So first of all, I'm going to go ahead and label it real quick. Min, Q1, Q2, Q3, max. Okay, the lower extreme is the same thing as the Q1, so that was 10. The lower quartile, oh, excuse me, y'all, I'm sorry. The lower extreme is another word for the minimum, which would mean this is the upper extreme. All right, let's start again. So our lower extreme is the minimum point, which is 4. Our lower quartile is our Q1, which was 10. Our median is our Q2, right? This is the same thing, which was 12. Our upper quartile is Q3, which is 16. And then our upper extreme is our max, which was at 25. Okay. The range of all of it is the max versus the min. So our max is 25. Our minimum was 4. So 25 minus 4 is 21. Versus the interquartile range, I take the Q3 minus the Q1. So my Q3 was 16. My Q1 was 10. 16 minus 10 is 6. The mode, this should be a nice little reminder, the mode is the one that happens the most. So if I look over here, the one that happens the most is 10. The mean is just the average. I can actually go back and look on my calculator. If I go back up, that X bar, this one, this very first one, is my mean. So I don't even have to sit there and calculate it. I just know straight up that it's 13. Now, if you wanted to calculate it the old school way, you would add up all of your values that were originally given, and then you would just divide by how many there were. So you would divide by, for this instance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So you'd add them all up and then divide by 10. Okay? Okay, let's do this real quick. What is the median of each set? The median of each set. So for the top one, it's at 70. For the bottom one, it's at 70. Which plot has a lesser range? So a lesser range, you can just look at how far apart they are. Look, B's at 100 and it goes to 40. Here, it's 100 and then it just goes to 50. So B obviously has a larger range, which means A has a lesser range. We're going to finish up the rest of these because we're running out of time. Which plot has the greater interquartile range? You would just look at the box. We're going to look at that later on. But here are your practice problems that I want you to focus on right now. Okay, you're going to use this stem and leaf, so go ahead and just read it all yourself. Pause the video. Here's your next one. Pause the video. Here's the next one. Pause the video. There you go. There we go. Here we go. All right. And then you're going to do the exact same thing that we did on that first page. And then here's the bottom.